my screen?
Yes, please go ahead.
You can share your screen. I already left.
Okay, so as everyone is aware, we created a document where we are basically asking everyone to come and to contribute. Okay, I don't think this should be a work just done by me and Nikos. I think the whole community should somehow contribute. Okay. However, if this is not the case, my suggestion is to close this document by the next Europe meeting next month. So what I'm going to do is to call for collaboration again so that people can comment on the document. We had a very interesting meeting, I think it was 2 weeks ago, where we look at specific problems, and Nikos highlighted the very interesting points. And there was also some other discussions. We created a focus channel on ROS agriculture, where we can have these discussions in parallel. The channel is called sig_datasets_discussion. And the main goal here is to make sure that we cover all the relevant aspects. Okay, so the document is structured as follows. So what are the main data sets available? What is the format of the annotations? Which annotation tools to use? How to annotate? And relevant publications. So we have already some very good contributions from people. I like that it's important that people had their names and affiliations to the contributors lists, okay, so that we know who is doing what. In terms of subject, I think we are now covering most of the relevant aspects. There are already most of these sections are already partially populated. So if we want to have success with this project, we really need that the community engage. And even if you feel that you don't want to write in a structured way that you are being asked, have a comment on the document. The document is shared with everyone, and therefore it would be very good if everyone could contribute on this subject. Well, and that's all from my side.
Okay, thank you. Thank you for your great work, but I don't know who else would like to contribute, because I think we have to maybe recruit more people. From my side, I know there's a huge association in France, because I attended agriculture. It's called FIRA. It's called, I don't know if you guys know this conference in France. So it's about agricultural robotics. So I met some people who are interested also joining this community. So maybe I can draft an email to send them and to see if there are more people interested in this
Yes.
working group, because I think we do not have enough people working on this. I mean, personally, I also have my daily job and I'm working on other things, and I'm super new to this dataset area. If I can try to help, but I'm really new to this area. So Pedro, if you would like to guide me, or
Well, I think you're already doing your share. We cannot expect everyone to be doing this.
Yeah, okay. Sorry, okay, that is from my end. I don't know who other else have other opinion.
Currently on the on Slack we have 31 members. Okay, if one of each member just write one contribution, then means that we're gonna have a document with around 10 pages. So this is more a call to people. It's not just enough to belong to the community. It's also important that people engage with the community. That's how we make it happen.
So this is guys just a question, Pedro, because last time we talked about this, I seem to remember a number of people in the meeting actually being really, really enthusiastic about this topic. I think I remember Kevin, is that correct, Karen? Kevin from Fraunhofer?
Yeah. Yeah.
Has he?
Who has been
Yes,
very
it's Kevin.
Who has been very quiet? It was basically me and Nikos and Celia on our last meeting.
So, but obviously it could be that with the current situation regarding the virus and, you know, companies basically shutting down, this could be just an unfortunate sort of, you know, combination of circumstances.
Yeah, yeah. I'm not pointing fingers. What I think is that an important subject like this one should not be just just three people deciding about the data sets. I think this has to come from more people. We need at least people reviewing and issuing their comments.
Yeah, no, I agree. I'm just wondering whether we can think of a certain, we can find a cause basically, but I'm not sure we can. It's not just here that we have trouble getting people to be more engaged. It's all over the working groups.
Yeah, yeah. Well, unfortunately, if you have lockdowns, people will have more time at home. So
yes, that's true.
Yeah, that's right. I actually had some comments on the Slack group about this topic. I myself I'm new to this as well, data sets and machine learning using this and so on. So I had a suggestion on actually a question on the group, if it will be not better, but at least like to channel the efforts if we find like kind of a topic that we can work on, and then like it will be like kind of practical thing, and like something similar to the loan tractor project, so we can have like kind of small project, and then like we can elaborate based on this. This means that we will have like kind of a common interest in a specific topic, and then we can build upon this instead of being sparse from several directions. So that's just a point of view, but it's just a novice point of view, since I have not worked on this before. So just like suggestion, if it's better to get like specific subject to start working on. So I don't know. That's just
well,
a point of view.
When I asked Matt Rotter to create a channel called Seek Datasets _ discussion, the main goal was basically to do what you are suggesting, so that we have a focused discussion on the, about important subjects regarding the datasets. And by the way, thank you very much for your questions. Your questions were very good. And again, we welcome people to comment. Okay, I know that some people are not very good. They don't like to work on documents. So if you raise a discussion on the channel, then I will make sure that your answers are made available through the document.
Yeah, I think we can have a good start to this. From our side, I will show on my presentation later on that we actually have quite our own database when it comes to hyperspectral images and so on. But of course, I will need to discuss this internally to see what we can share and what we cannot share, and so on. So like at least to contribute a bit of with what we have as data, but we can use the available open source data as a beginning to build on. So, but we need just to continue this discussion to channel the works towards a specific goal.
I fully agree with you on that.
Yeah, that's good.
Okay, so Pedro, do you agree that, because I was wondering like if I should like draft an email to the group of people I just mentioned, that it's a huge agricultural robotics association in France. But previously I didn't know, I was not sure that if I should contact them, because I was afraid that there will be too many people in this community and it would be really hard to handle at the meeting. So, but apparently it seems like we are lack of members to work on this specific topic.
I think you should, because what happens is that when you have a community, we have a few inliners and we have several outliners, okay? And the outliners, some of the outliners will only join and become inliners once they see that the community is engaged and working, and that we are organized and that we know what we are doing. And I think this is the case. We know what we are doing, and now we just have to start bringing more inliners. And then it becomes something natural, I would say.
Okay. Then I will do this. Okay, thank you for your advice. So I think we can move on to the next topic. Shab, would you like to give your presentation on multi-vehicle navigation?
Yep.
Do you like to share your screen? Probably it will be easier for you to navigate.
Yeah, I will share the screen. Do you see the presentation or?
Yes, I do.
Okay.
Yes.
Yep. So I think I gave already I would just like to mention again, my name is Shoaib Harik. I am a postdoc research fellow at the Norwegian Institute for Bioeconomy. I would like first to just like give an overview of our institute. It's basically a research institute owned by the state, and it's almost all over Norway. We have different research stations and really different broad topics: food production, water analysis, anything related to the environment and society and food and so on. The Center for Precision Agriculture that I belong to is part of the food production and department, and it's located in a place that is called Appelsvoll, which is around 2 hours northern Oslo. And we are the biggest research station of NIBIO. We have our own field trial.
Shuab, sorry
Yeah.
to interrupt. I think there's a maybe you are too close to your microphone. Something, there was quite lots of noise
Oh yeah,
in the
okay, sorry.
background.
What about now? Is it better or?
Yeah, it's better.
Okay,
And
yeah, sorry.
it's okay. And I think are you sharing also, you like you are not just sharing your screen, you're also sharing your presenter's view. I don't know if this is what you wanted.
No, this is not what I want. I don't know how to. Okay,
You
maybe.
probably have two monitors, and you are sharing the wrong monitor.
Oh yeah, that's true. I do have the laptop linked to the screen. Maybe I'll just
If you
unplug
stop
the other
sharing,
screen.
and if you stop sharing, and if you select to share again, you'll be able to select the correct screen.
What about now?
Now, yes. Now it's perfect.
Okay, yeah, I just unplugged
Yes.
the other screen. Use just the laptop.
Yeah.
Okay, yeah. Yeah, okay. So that's just a quick overview of where we are working. Now I'm just going to give just quick overview on what we are doing in the Center for Precision Agriculture. So we have mainly 4 topics: precision weeding, precision fertilization, data collection, and multivariate statistics. And the last part is mainly what I'm working on, is the using robots in agriculture and automation system. Today I'm going to, this is as well like some of what we have as sensing product. We use multiple sensors. We use a lot of UAVs. We have as well like handheld sensors, tractor mounted sensors, robot mounted sensors, and so on. So we have different outputs from normal RGB aerial images to hyperspectral images, and content with detection, water stress, and so on. So that's why I said like we have our own database, because we do a lot of flights over the fields, and since we have our own field trials, so we collect our own data. But we haven't made this public yet, so this is still an internal debate about this topic. I'm going to talk mainly today about a project that we're working on, which leads to the multi-vehicle navigation. The project is called Solar Farm. That's the small title. The long title is Exploring Solar on-Farm Energy for energy production, and the main and with fleet of electrical vehicles for reduced greenhouse gas emissions. So from the title, there are two objectives. Is to reduce the emissions from fossil fuels-based tractors, so replace them with electrical ones, and improve the nitrogen use inside the field. I'm going to talk really briefly about the second point at the end of this presentation. So if we summarize, the goals of this project are to firstly reduce the emissions from the tractors, and reduce as well the emissions that are from the use of the inorganic nitrogen fertilizers. So to reach this goal, to reduce the emissions for the tractors, we have as an idea is to replace the fossil-based tractors with electrical ones. However, the big problem now is that we don't have really commercial available solutions or commercial available electrical tractors that can replace the conventional ones. So if we take, for example, a 150 horsepower diesel tractor, to replace it with what we can buy right now, because we've been looking really for a long time to get like hands-on electrical tractors, but we couldn't. We just got one producer in California that was able to build something for us and ship it all the way to Norway. So if we base this on, the replacement on this example, we will need 3 electrical tractors in order to replace one diesel, a conventional one for 150 horsepower. However, if we have 3 electrical tractors inside the farm, so the main problem is how are we going to drive these 3 tractors at the same time? Because we want to replace this and we want to stay as effective as we have 1 tractor. So the solution is to hire 3 people to do this job, which is not a good idea and no one will accept this. Or to still have 1 driver for the tractor and make the 2 other ones follow autonomously. And here comes a part of the multi-vehicle navigation. So we want to actually have a solution that can be applicable on real life scenarios, which means that we will need a human being that's like following the regulations. We will need a human being to supervise the autonomous machines at all time. And to do this and to have this solution applicable in agricultural context, we need to have the farmer driving a tractor and then having like 2 other tractors or robots that are following at the same time. This will make, for example, the working with 2 times or 3 times, or it depends how many tractor or vehicles are in the system. But if we take, for example, a fertilizer boom of 12 meters, and we have like 2 other robots that are following, so we have like 12 multiplied by 3. So we have like 3 times the width working with only 1 driver. So to do this, we need to have a full communication between the vehicles. It means like that we have the leader, which is the manned tractor, sending the information to the other ones, and the other ones are following according to this. And to do this, we have a navigation scheme. The navigation scheme means how are we going to do the following. So we have 2 parts. Mainly is when we are driving to the field, we are driving basically on narrow roads. It means that we cannot drive side by side. So we need the follower or the unmanned tractor or the robot follow the the manned one, yeah, behind. And then like once we are in the field, we decide we need to say to the robot that now we would need to switch the navigation scheme to drive beside. This should be like on switch of the button, or we just like define the zones where we can switch the navigation scheme. So that's an example that we have on our station. So I'm driving this small electrical tractor, and behind we have a robot tractor. So it has basically the same power, autonomy, and so on as this one. It has 3-point lift behind as well. So this is just like to showcase the idea. And then what we have here, we have master-slave communication. So we have both of them have RTK GPS. So we have our base station that is on another building here. So here basically we have the first scheme where we are driving, where the robot needs to follow the tractor behind. And then like, I'm just like simulating here, I'm going inside the field. I say now the robot needs to change its position to drive behind, to drive aside. So we can see that the robot starts to change its position to drive beside the tractor. Well, that's the RTK base station. And then like I can switch back. I tell the robot to switch back to drive behind me. And this is just like to show that we have a full communication between these two, and it's working fine with the GPS and the heading and so on. We will work more on this to try it in a real field because I only had this place to play on. So I will need to have more place and need to have some other technical issues to make this look a bit better. The next thing is that we want to have an autonomous charging scheme. It means that since we are going to, or basing the idea on changing the fossil-based tractors with electrical-based one, we need to think about recharging the vehicles. And we don't want the farmer to go down and drive the robot to the electrical tractor to the garage and then plug the cable and so on. We want to have an autonomous scheme. It means that if, for example, one of the vehicles inside the fleet needs to charge itself, it can do this by its own. It means that when it needs a battery to be recharged, it goes to the parking zone, parks inside, and then we have another small robot to come and plug the cable. There are other solutions where you have the chargers on the ground or something, so you don't need a mobile robot, but or use an arm or so on. But we have investigated like different solutions. We came out that with conclusion that this will be the cheapest and the most convenient way to do this is to have like small cheap mobile platform with normal cable and just like come and plug the cable instead of using the robotic arm that may in most cases cost more than the robot itself. So that's we have an example of this thing. So here we can see that, for example, we have the robot that is going to park inside the garage. And then we have simple, really simple vision-based tracking on this mobile platform. It's an omnidirectional platform. You will see how it will move. So and then like once it detects this tag, R tag, it starts to move slowly. And then just to give an idea how it will work is that it goes slowly and then plug the cable. And here we have only some LEDs on the tractor. And once we have like a good connection, we have a small battery here that is going to transfer the energy from this side to this side. But like the final thing, we'll have normal cable and then plug the real power cable on to the tractor to charge it. Another point that we're working on is to have a complete system that includes a server. So in the system, we have, for example, UAV for scouting missions. We have a graphical user interface for the farmer to have an overview on the vehicles and so on. And we have the vehicles in the field. So we have two types of communications. We have a machine-to-machine communication, which is basically the one between the vehicles inside the field, as we've seen previously. And we have the machine to the server communication, which is from each vehicle through GSM or 4G to the server. So we can monitor and supervise in real time the position of the vehicles, do some task allocations, and so on. So in the next, I'm going just to give an overview on the graphical user interface that I've developed to control the vehicles and see the place. Unfortunately, I cannot share the video because this is a work in progress. So, and we want to write a paper about it. So I'm just going to share some screenshots and so on. But basically, this is a ROS bridge with HTML and with to have like communication. So that's what I've developed here is that I have user interface where we can see, you can see here, that's the research station that I've shown previously. So we can see the GPS position from the vehicles where they are inside the field. And then we can see as well the video feed. We can see the camera, we can see the battery level, and we can assign some basic tasks. For example, here we have follow waypoints task for the robot. And when we click on this, there is a mission plan, which is just like few waypoints that are assigned to the vehicle. And the vehicle just goes, go and follow it. And then we can, for example, click on go back to the charging station, and then the vehicle will go from the field to the charging station, which is here, and then go and park inside as I show on the video previously. Another thing is that we can as well control the charging thing from the graphical user interface. Basically the same way, but just like doing it here. And all what I've done here was from my office, and everything else was in another location in the station. So it's basically working fine. So I'm quite satisfied as so far with the result. And here, like, we click on the plug the cable, and everything else will be autonomous. So like the charging station will go plug the cable, and then there will be a communication between the robot and the charging station to show to tell, for example, the level of the battery. And then once, for example, the robot that is called Alvin is charged up, it will tell the charging station, okay, now my battery is full, so you need to unplug the cable. And then, like, since we have like this communication between two, the charging station will know that the vehicle is fully charged, and it will start driving back to unplug the cable. And now I'm just going, as I said, to give really brief overview on the what we are doing to reduce that. That's really a totally different topic, but just to give short overview on this, how we're planning to reduce the emissions related from the use of the inorganic nitrogen fertilizers. Of course, we need to do some scouting missions to have the information about the fields. Based on the data that we are going to collect, or we collected, we can define based on agronomical model to extract the application map. It means that each place or the plant where the spots in the field, the plants needs more or less nitrogen. This means that we're going to give the plants what they need and not have the same nitrogen fertilizers all over the field. And to do this, we've developed the first prototype of a precision sprayer, and now we're developing the second one. I can show just quickly this here. What you can see here, this is the second generation of the precision fertilizer applicator. This is more robust, using better components, and here we're doing the calibration stuff. But the first one was a simple solenoid-based sprayer. which just take the application map and then like do an on-off mission. So here the example is really simple, that we want just to show off the idea, and then we have the tractor and we are trying to spray Nibiu on the ground. So we just wanted to show that we can control each nozzle individually to do whatsoever pattern we want to apply on the ground or in the field. So that's just an example of how we want to tackle this problem, and this will be the end of my presentation. So if you want to have any information about what we are doing, whether you can contact me or take a look at our website. It's precisionag.no. And yeah, that's all. Thank you for your attention, and if you have any questions, please don't hesitate.
Yeah, thank you, Shrav. Thank you. That's great work. So, does anyone have question? I have one question here. So I would like to know, like, what is like the biggest challenge you have faced so far for your work? Like, it seems like everything's working perfectly, but I'm sure there's must be some other challenges.
Yeah, not everything is working perfectly. You know, like when you're doing robotics, you only show the fancy videos. You have
Exactly. That's why
you show
I
only
asked.
what's working. Yeah, yeah. You have some problems like I have, for example, if I limit this to the topic of this presentation is the multi-vehicle navigation. I actually began using the master-slave architecture, but I'm going to switch this to what I'm doing now between the vehicles, to not use a master-slave but use asynchronous communication. Because the problem with the master-slave communication is if you have a problem with the master, then you will have a problem with the slave, and this is not optimal inside the field. So you need to have each entity independent of each other. So what I'm using now on the server part is that each vehicle is independent from anything else. So they just like talk, share their information, and then they receive the information that they need. So in case, for example, I have a problem with the tractor that is not communicating something, the robot won't go crazy. It will just like give a signal, okay, I don't receive something and I'm just staying where I am until you fix this. But if you have like this master-slave communication and you have like a sudden, this happened to me inside the field sometimes, if you have like a communication that is lost between the two vehicles, the robot will just like go crazy. Maybe there are some workaround about this around this, but I haven't actually had time to look into this. But there are many problems with this. Another problem is the heading. It's really a big issue inside the field, especially like we found out that we have some spots where we have really big electrical interference that is affecting the IMU. So what I basically used on the video that I showed when the robot was using the tractor, I basically used only the GPS to estimate the heading. So you just like have two successive readings, and then like you just estimate the heading. But the problem with this is that when you're in a stationary position, when the robot is not moving, you won't be able to estimate the heading of the robot. So you need the robot to start moving in order to estimate this. And another workaround about this is to install the second GPS antenna, and then like with the known distance between them on the robot, and then of course you will estimate the headings based on both of them. But yeah, this means that you will be dependent on the RTK base station or another RTK provider. But this is not a problem for us. We have a static one, and if we don't receive this, I made a mobile one, so I can just take it wherever I want. So that's one of the issues that we basically have. But of course, there are a lot of issues and kind of philosophy on how you want to make the communication best and how to tackle the problems, because once there is a huge difference between imagining the solution and having the solution in the field. So but yeah, I'm going through this step by step.
I have a question. First of
Yeah.
all, thank you very much for your great presentation. Um, I know that you are handling a lot of complex variables. You mentioned one already in terms of navigation, which is a nightmare, especially when you lose the communication, and that probably requires some some ways of tackling this situation. We have a person on the group called David Portugal, and he has been working on this subject for some time. And I suggest that you get in touch with David, because I'm pretty sure that you guys will be good partners trying to solve the same problems. Another question that I have you considered to use solar panels on both tractors? Because even if you can, even if you have a system that can come to the to auto charge, it could be it's always desirable that the system has somehow of trying to use some of the energy produced by sun or something like that to increase the autonomy. And the other question that I have is regarding the robot the charger robot, okay? Because it's simpler when the tractor is very clean, but as soon as the tractor starts to go on the field, there are all these dust and moisture, and that may make very challenging to be able to charge using contact.
Hmm. Yeah, thank you for your feedback. The first one, yeah, I will be more than glad to be in touch with your colleague. So probably you can invite him to join the Slack channel, so we can discuss more about these topics. The second point about using solar panels on the vehicles, for our case, this won't be much effective because you will need really huge surface in order to provide enough power to run the vehicles. We have these are lightweight vehicles compared to the tractors, but they are really heavyweight compared to normal robots. We have a 50 horsepower electrical tractor, and the robot tractor is as well able to have, for example, 750 kilograms of weight lift. So it requires really huge amount of power, and we are in Norway, so basically using the solar panels inside the field won't be much effective. That's why, like, we're thinking about just going back and charge the robots as they need, or the tractors as they need to charge this. And why we are using the solar panels in the project is that like when we are in the growing season, it won't be like much clouds, so we can get at least like a bit of free, or not free, but clean energy back to the system. So that's why we're not considering for now, at least for this robot and for this tractor, to install any solar panels on the roof to provide some energy, because we just think that it's not this efficient. And for the third point, the charging, for the charging station, actually, that's why we mainly didn't want to make any fixed charging station that are based on contacts. But our solution that we've seen now will be based on the lead that opens and closes. So like when the robot is inside, the tractor is inside, you can have the lead that with a small servo that closes the charging charging port, like for example in electrical vehicle, or for example in your diesel or benzene vehicles, you just like open the lead to plug the to refuel it. It will be the same. It won't be like exposed to the elements outside. So that's why it won't be a problem to use this with the contact. But the final solution won't be based on simple point-to-point contact, because this will be not efficient. It will be risky if you have like small distance between this with sparks and so on. So it will be really, really risky. So we're actually in the process of talking with with the company now to see if we can provide some wireless charging solutions or other solutions that are more efficient than this one. But the one that I've shown on the video is just to show the idea that we are able to transfer the energy from one side to the other side. But of course, the filing solution won't be based on just contact to contact. This won't be safe, and nor will be it will be efficient.
Thank you.
You're welcome.
So we had a question in the chat actually. I'm not sure whether you saw it.
Yeah, I just opened it now.
It was from Ilias.
Yeah. I have a small question. The path following and
Yeah, he asked, have you seen it?
yeah, yeah, actually I did. The path following, I'm not using any packages. Maybe this is stupid, but I sometimes I find it a bit difficult to use the available packages because they rely, for example, on odometry and on a lot of other sensors that I don't have on my robot. So usually I do use my own stuff. For example, the path following is just like waypoint navigation, so it's quite simple to make it. And yeah, so that's the first question. And yes, I developed this to the low level as well. The Pixhawk, I'm using the Pixhawk only for the example of the robot. I'm using the Pixhawk only to get the information of the GPS and the IMU and stuff. I'm not using it for the path following and so on. The thing that I've shown on the example with the waypoints, I created something that you can just have a similar format on the Pixel on the mission planner, for example, and you export the file to the robot, and the robot, I have like a node that reads this, and then like just give this to the node that I've written, and then like we'll just follow one waypoint after another. So I just wanted to do this so we can use, for example, Mission Planner to create the waypoints and then like upload this to the robot. Why I want to do this is that I want to have something that is a bit generic, so we don't need to be dependent on whatsoever. Like for example, the Pixhawk, like this example, you don't need actually the Pixhawk as long as you have a GPS and you have like this mission plan file. You can do it manually, just like have a list with the mission plan numbers and the location of each waypoint, and just like upload it. So that's the second question. Are there any other questions on the messages?
No, I believe that was it, Mason.
Okay, yeah.
Just a quick one. I shared a video from Simon Blackmore from Harper Adams related to the weight of the robots, where he suggests that the future robots should have lower weights to reduce the footprint. I think it's a very interesting talk, and he explains why the robots should have a very low footprint, because most of the money that we spend yearly is just unpacking the soil that was packed through because of the robots going through the field.
Yeah, but yeah, that's a good point. But actually, we're in the transition phase here, at least for our side. So the transition phase is that we want to have a transition from a 150 horsepower tractor that is really heavy to a 50 horsepower tractor on robots that are less heavy. And of course, the next step is to have less heavy, like more lighter robot. But the problem is that there is a balance that needs to be found between what is effective in the field, because we don't want only to have fancy solutions and fancy robots that are going inside, but something that can do the job. And if you have something that is really lightweight, you won't be able to do the same job as a normal tractor that can do, for example, plowing and other heavy duty stuff. So that's why, like, there need to be a balance between these two aspects. Of course, the best is to have like really lightweight machinery inside the field, but this balance needs to be taken in consideration, especially if we want to present a solution to a farmer for adoption. So we need to have something that can be acceptable and that can be usable inside the field.
Okay. Thank you.
You're welcome.
Okay, thank you very much. Thank you for your great workshop.
Thank you.
I think we have to move on to the next item because we are running out of time. And Theo, are you here? Am I pronouncing your name correctly? I guess
I
it's
am
Theo.
here. Hello, can you hear me?
Yes.
Very good. Yes, goedemorgen. Ik ben Thilo. And it's a silent H, correct.
Yeah, do you want me to share, or it's better you share? Okay, perfect.
Is it shared now? Can you see my presentation in presentation mode?
Yeah, yes.
Soon, like this. Hi, my name is Thilo Zimmermann. I work for Fraunhofer IPA. I'm today speaking in case of, because Christoph Hellmann is sorry, but he cannot attend this meeting. Next slide might be very dumb, but as I was not sure who's in the call, just what is ROS? ROS is open source. It's a meta operating system for your robot. It provides you services, hardware abstraction, low-level device control, etc., providing lots of tools and libraries, and it's also an ecosystem and a de facto standard. So I think at Fraunhofer IPA we use ROS since 2012, and we already thought it's a big thing, and ever since it's been growing. Not expansionally, so it's not a pandemic, but at least it's growing a lot. So what's then ROS-Industrial? ROS-Industrial is an initiative promoting software innovation in industrial manufacturing, as ROS in the beginning was mainly in research and mainly on a humanoid robot called PR2, and maybe on very not that industrial robots. So we're leveraging open source software. We're collecting industry specific needs, combining the strength of community-based and contract development, and also identify and clear non-technical obstacles, such as regulatory or legal issues, licensing, code scanning, I don't know, that kind of stuff. ROS-Industrial is also a software suite, platform for robotics and automation. It reduces the vendor lock-in for its users. So if you usually use a Kuka robot, you cannot take your code and use it on an ABB robot. If you've used ROS before, then it's just a different driver and a bit more of work, but at least you're not locked in by your OEM, by your vendor, into one specific robot and one specific robot programming language and training, etc., etc. It also provides a rich infrastructure for system integrators. Some of our members, let's pick, as we just had somebody from Norway speaking, we could take oh, come on. Gijs, you're on the line. I'm stuck. PPM Robotics. They're from Norway. They're a system integrator and they use ROS, so it provides some rich infrastructure for application development, and also allows OEMs to complement their hardware with a vibrant ecosystem of software. Take Universal Robots from Denmark. They had a nice presentation last year at the ROS-Industrial conference here in Stuttgart, where they show how you can complement what they're doing with on their own and with what the ROS-Industrial or the ROS community is doing. Brief history. I think this is what Christoph promised you is so like if I maybe you see my mouse here in ROS-Industrial Consortium. So this idea started in 2012 when somebody of the Southwest Research Institute in Texas and somebody from Fraunhofer IPA went to to have an intern at Willow Garage. That was a startup back then that developed ROS, let's say. And they both realized, okay, this is really interesting also for our more industrial customers. And if we go back 2 slides, that was 2012. So it was really interesting already at that time. And so they went back to their organizations. Well, sorry. For here at Fraunhofer IPA, we could convince our internal organization to fund. Sorry, I have to mute my telephone. Okay. So we received some Fraunhofer funding to go further with the topic. We had our first conference in 2012, which was called "Is ROS-Industrial an Enabler, or is ROS an Enabler for Industry?" ? I think ever since we realized it is an enabler, and we don't need that question mark anymore. Our colleagues in the US then launched a ROS-Industrial Consortium in 2013. I think at Fraunhofer IPA, it took us a year longer, and we started in 2014 with 4 members. So that was then the ROS-Industrial Consortium EU, RIC EU. And since 2017, we have the ROSIN project, who is supporting this, this consortium. Meanwhile, we have some in the mid of 20 members in Europe and around 80 members worldwide. And our ROS-Industrial conferences last year and the year before had basically 150 attendees, 2.5 days of program, lots of presenters from industry, from research, and we could say it's on the right you can see all the latest member slides, or the latest members. So TU Delft is in there, etc., etc. So what does it actually take? What kind of activities are needed to create a consortium? Well, first of all, you need some kind of a common vision or a roadmap. What are you trying to head for, or why you want to bring people together? And then a lot is about information exchange, formal information, and sometimes also informal information. If you just meet, bring them together, then you help yourself, or can clarify a lot of things. You might need something like working groups, developer meetings, and from our perspective, it was always good to have this flagship conference with technical and with management talks, where you can always refer to, and then another company sees, okay, if X is doing this, why are we not doing this? Or if Y is seeing this as more than an opportunity, we should also look into this. And then, yeah, of course, you need a website, you need social media, and so on and so on. Company relations, yeah, you need to meet with a lot of companies, understand what their problems are and how this can help them. You need to also talk with experts in the field. What is actually possible? Are those industrial needs? Can we achieve them, or when can we achieve them? And overall, yeah, convince a lot of companies to make them understand that it's better to join forces than yeah, for each other to start reinventing the wheel again and again and again. So what you then actually need is a lot of demonstrators to attract the industry, to push technology solutions out there, to where you see, okay, this is actually technologically possible, and also maybe to convince companies more what is actually needed in the market. It doesn't always have to be a perfect video. Also, an animation can give a good idea of sorry, I was gone. My headset disconnects every 25 minutes. Are you still there? Can you hear me?
Yes, we can.
Okay. Yeah, and then overall, you need demonstrators to show value and give people to believe why using open source, why using advanced algorithms, advanced solutions, etc., etc. Advantages of a consortium are for companies and for developers to get access to new developments within the community, have domain experts to support them with their problems, have a network of potential cooperation partners that have similar problems that, again, want to join forces, and then for researchers, again, of course, have a network, but here maybe also with other research institutes and with other companies working in the same sector, showing the relevance of what you're actually doing. This can be so it can be for the marketing, can also be the own management, can also be for proposals, project proposals, where you can show, okay, there are these X companies in our consortium and they are needing this, or after our EU-funded project is over, we will have this sustainable network, and it already exists. Even maybe in case of ROS-A project, I think it was a good asset to have the ROS-Industrial Consortium there to say, okay, we have a consortium, we have an EU project for 4 years, and then we'll have the consortium afterwards. So that gives a lot of more confidence and continuity of the work done. It gives a credible exploitation strategy for research results. Like I said, beyond the project. So even if the project is over, we still have this consortium where you can exploit your results, and you also can get closer contacts to companies for actually doing your tech transfer. That, at least for RTO, like Fraunhofer IPA, is also a very big asset. So overall, a consortium can boost knowledge and tech transfer. But of course, there's a disadvantage, and there are, of course, lots of disadvantages, but it takes time and it takes a lot of effort. If you take the example of the ROS-Industrial Consortium, It's of course ROS at is was not that.
Sorry, Kilo, to
Yeah.
interrupt. And how many slides do you have?
I'm done.
Because oh, you're done. Okay,
Thank you.
perfect.
Okay.
Sorry, because we are running out of time.
Okay.
So, does anyone have? I mean, thank you for your presentation. I mean, it was really clear, but again, I do not really know if we should have consortium. Maybe guys, you have lots of experience on this. Could you please make a comment on this?
Well, I have a slightly biased viewpoint here, obviously, but I think this is just another point of, another bit of information that we now have about this, and what, from the point of ROS-Industrial, the advantages are of a consortium, and whether that is something for ROS Agriculture is something that only the community can decide, I believe. So I don't necessarily have an opinion on whether or not ROS Agriculture should have a consortium. I just believe that this is a good example of an environment where it worked. And if we see sufficient reason to, create one here in ROS Agriculture as well, then we could definitely consider that.
Yeah, I also agree, but I think it's a bit too early at this stage to think. I mean, to start to work on this. But of course, we can think about it we can visualize this in the future. But
We
I
don't need to
know.
decide now, so that's not.
Yeah, we don't need new design now.
I think we already had like kind of similar discussion before in the beginning.
Yes,
I just
exactly.
want to underline something about this. I think this will be like kind of a natural thing to come after when we're a bit ahead working with this. Why the ROS-Industrial had a consortium, because like ROS was used for commercial use. That's why like it's growing big in the industrial part, which is not the case in the agricultural part yet. So that's why like it would be like a bit difficult to have something similar, but we can at least follow the steps of the ROS-Industrial and join our efforts to go a bit deeper with the collaboration. And again, this will be like a natural thing that comes after, I think.
Okay. One thing I cannot say much about agriculture, but I can say in 2012 this was not an industrial thing. Even 2014 it was seen as a research thing, and lots of companies were really unsure and even biased against ROS. So just looking from it as it is now is not what it was when the consortium was set up. So at the beginning of the consortium, it was really about convincing industrial partners of using open source in their production or in their robots, letting them understand the benefits of having that kind of a programming approach, of having open interfaces, etc., etc. So it was a lot of convincing work.
I think that the benefit of the consortium here was mostly that, or not mostly, part of it was that, if you talk to larger corporations, they're used to these kind of management structures. So if you don't have this, but I'm not saying that it's a binary thing, but it looks like an open source hobby project. And I'm saying this, I'm basically quoting the people that we talk to a lot, at least in the beginning. So, but if you have a consortium, it already looks like there's an organization behind this. It's people who have a higher or a longer term vision. It's people that, are also maybe even used to those kind of management structures. That may not necessarily be the case, obviously, because it would be us basically sitting in this consortium. So it could still be the exact same people, but it's almost marketing. This is not how it's perceived anymore. A consortium is at least a bunch of organizations that have decided that this is worth investing some time and money. And it gives it the outward appearance of a properly organized and maybe even with a vision sort of group of organizations. And I think it's mostly, no, not necessarily mostly, but a large part of it is marketing, especially if you're trying to achieve I would say almost recognition and maybe even something like acceptance. And I think that's, you get to make these kind of nice montages, logo montages.
Yeah.
And this is basically, you know, people will be seeing this and saying, oh, wait, these guys are all in here. So that and it's obviously completely a bogus argument, but if these guys are in here, then it must be, you know, a proper sort of serious thing to maybe also spend some time looking into. And I think that's one of the biggest advantages of having a consortium that you can get, because as Tila mentioned, it's really a lot of overhead in organizing all this stuff and, you know, talking to all these people, and it's mostly networking actually also.
You can actually see that Lally is a ROS-Industrial consortium member. Of course, those companies who are interested could also join the ROS-Industrial consortium, and within the ROS-Industrial consortium, you could have a agricultural topic group or something. But I'm not discussing into your topics. I'm not discussing into you. I'm really biased, and I'm not too much into your project. There are companies approaching us and saying, okay, we want to be on this list. They just also use this then for their own marketing almost. They're of course very active partners, and some partners just want to be on that list, have then logo on such a logo montage.
Yes, but that almost makes it sound like it's a disingenuous thing. It's more about just the fact that there is an actual organization behind an initiative, instead of it being just I would almost say a random collection of interested individuals.
No, that's okay.
You can't actually, you know, deal with a random collection of individuals. So especially not from a company perspective. So I guess that's what I was trying to say. You know, it's a single point of contact, you know, an organization, those kind of things. That would be the biggest advantage that I've seen from having a consortium. But that's, you know, again, we don't need to decide right now. So thanks, Tilo, for providing the extra input.
You're welcome.
Yeah. Okay. I think it's already quite late, so thank you everyone for joining. I look forward to the next meeting, and be safe, everyone. So thank you, everyone. That's the end of the meeting.
Thank you. Bye-bye.
Thank you. Bye-bye.